ticket for success on all the things that we're going to do for the rest of the unit. I want you to make sure you keep this handy in a place where you're going to be able to reference. You can use this as a study sheet. These are all very good ideas. You guys have the next 3 minutes completely on your own, no help from anybody. Fill in as much of this as you possibly can, and then ILA is going to do her thing and start randomly picking on teenagers. Now there. That you didn't do part? That's why I put D with a question mark 013. All right, friends, let's do it.
Why is approximation request?
What?
Approximation request.
We'll talk. All right, Ile. When Ile calls your name, you get to fill in any box on this sheet. Pick the one that you're more comfortable with. Ile, which one? Palimon.
Vertical tangent line is a vertical axis.
If F has a vertical tangent line, then F prime has a vertical asymptote. Now, for the sake of time, I'm being a little bit looser here. I'm not worrying about the at x equals c, but that's implied. Okay, Eilay?
Aaron.
Aaron, give me another one.
F of x is increasing, f prime of x is greater than 0,
Yes.
x equals c.
Okay, if f is increasing, then f prime has to be greater than 0. Nice. Next one.
Carmen.
Carmen.
If f of x is decreasing and f prime of x is negative,
Negative. And since Aaron did all the hard work there, why don't you pick another one?
so if f of x has a relative maximum, then f prime of x changes from positive to negative at x equals c.
Changes from positive to negative. I don't want to hear equals 0. That is not the same thing. It is a very specific change. All right, Eilay, next.
Andrew.
Andrew.
If f of x has a critical point, then f prime of x at f of x equals 0 or does not increase at x
Love it.
equals c.
F prime of x equals 0 or does not exist. Well done. All right, next.
Giselle.
Giselle.
If f of x has a vertical asymptote,
If f of x has a vertical asymptote,
then f prime has a vertical asymptote at x equals c.
then f prime has a vertical asymptote as well. Nice. Next.
David.
David.
If f of x has a saddle point, then f prime of x is equal to 0 but doesn't change sign.
Equals 0 but does not change sign. Love it. Next.
Steven.
Steven.
If f of x has a vertical tangent line, then f prime of x has a vertical asymptote at x equals.
Oh wait, hold on. We've already done that one.
Oh,
But hey, good reading. Okay.
oh, for f of x has a cusp point, then f prime of x does not exist.
Okay. If f has a cusp point, f prime does not exist. Good. Next.
Celeste.
Celeste.
If f of x has a relative minimum, f prime of x changes from negative to positive.
Changes from negative to positive. Next.
Myra.
Myra.
Horizontal asymptote.
If f has a horizontal asymptote, then f prime.
F prime approaches 0 as x approaches infinity.
F prime is going to approach 0. Now, you got to keep in mind with horizontal asymptotes, you could be talking about as x approaches positive infinity, or you could be approaching as x approaches negative infinity. Whichever side you're talking about, that's where the derivative has to approach 0. All right, next.
If f of x has a horizontal tangent line, then f prime has a root.
F prime has a root. F prime is equal to 0. Oddly enough, no one is touching any of these other ones, but we're good so far. All right, monotone increasing just means that's all that the graph does. It increases. Not necessarily in a line, but it
What's it?
increases. That's all that it does.
What's it?
What's it? Good question. Have I told you I'm not feeling well? Remind me to cough on your paper later. The function is monotone increasing. Can somebody give me an example of a function that is monotone increasing? That's all that it does. Think parent function. Y equals, what a boring function. All that it does is go up. Y equals x. Give me another one. Another parent function, all that it does is increase. It never does anything else.
Square root of x.
One more time.
Square root of x.
Square root of x is like that. Other ones. Those. The natural log of x, really boring function. All that it does is increase. That's what we mean by a monotone increasing or strictly increasing. So think y equals x, think y equals e to the x, think y equals the square root of x, think y equals the natural log of x. In all those cases, f prime is positive. Strictly positive. Everybody good for monotone decreasing? Right, think something like y equals e to the negative x. Think about y equals negative x. F prime is only negative. All right, now let's make sure that you guys really are ready for the real quiz. Eilay, let's keep pulling some names, shall we?
Luis.
Luis,
So
if f is concave up, what do you know about f prime?
it's increasing.
I'm sorry, what?
Prime is increasing.
See, if somebody's going to kick me, I'm going to go around kicking you. So if f is concave up, f prime is increasing. All right, Eilay, keep it coming. Give me more victims.
Me.
You. All right, if f is concave up and f prime is increasing, then f double prime
Has to be positive.
Has to be positive. All right, and tangent lines are located where? Next person.
Luis.
Luis.
What?
Yeah, how does that work?
Because I had to restart the.
Oh, she had to restart. I'm sorry. Okay, F is concave up. F prime is increasing. F double prime is positive. Where are those tangent lines?
Above.
Think about concave up. Draw concave up.
Oh, the below.
Concave up. Those tangent lines have to be below. So your approximation is,
Under.
it's an underestimate. All right. Secant lines, we'll talk about those in a little bit. All right, next, Eileen, who's up on the chopping block?
Giselle.
Giselle, F is concave down.
F prime is
F prime is
decreasing.
decreasing. Giselle, while you're on the hook here, what do you know about F double prime if you're concave down?
It's negative.
Negative. And what do you believe about where the tangent lines are located?
It's above.
They are above. Isn't this so nice? And what do you believe is going to happen with the approximation? Overestimates. Love. Not overstated. For those of you that are going to be tempted to go overstated. Overestimate. All right. Next, Eileen.
Carmen.
Carmen, F has a point of inflection. What do you know about F prime? F has a point of inflection. What's happening with F prime? F prime is changing. Let's be specific about the change.
From positive to negative.
There is something that changes from positive to negative or negative to positive. It's not F prime though. Point of inflection would be like something like this guy right here is your point of inflection. Before you get to the point of inflection, you're concave up. F prime is increasing. After the point of inflection, you're concave down. F prime is decreasing. What the change is you're making a change from increasing to decreasing, or it's a change from decreasing to increasing. It's F double prime that is going to change from positive to negative, or the change is going to be from negative to positive. All the friends okay? All right, real quick, let's wrap this up with secant lines. Okay, we talked about with our friend concave up, second derivative is positive, and if the smile represents the curve, then that green line there represents the tangent line, and the tangent line is below the graph. So everybody okay? But what if I picked 2 points and connected them with a, what kind of line? Secant line. Where does that secant line live? Between those 2 points where we're intersecting the curve, the secant line is actually above the curve, not below the curve like the tangent line is. For concave up, tangent lines are below, but secant lines are above. And if the secant line is used as an estimate, if you said, hey, what's the value at this point here, and what you used was the secant line, what you're going to get is an overestimate. If you try something similar with concave down, pick 2 points, there's my secant line. My estimate is going to be an underestimate. I'm sorry, my secant lines are under the graph, and what I'm going to get is an underestimate. Okay, that honestly is about it. That's like all the big ideas, all the things in one place. Do not lose this gold sheet. Oh, it's going to be helpful. Here's what I want you guys to be able to do for the next 25 minutes or so. If you turn the page over to page 30, this is something that I would recommend you put a star next to. This used to be what I would call a journal entry. Journal entries are excellent preparation for the unit test. They're excellent preparation for the quiz that's coming up. Right, so I'm looking on page 30. Here's what I want you guys to do. We need to do about the next 10 minutes. Using the graph, only using the graph, I want you guys to answer as much of A through F as you can. Remember the conversation we had yesterday? Number one, make sure you know what this graph is. Is this the graph of F or is it the graph of F prime? It makes a difference. Number two, make sure that when you're answering a question like on what interval is the graph of F increasing, what I need to see is I need to see your justification, a very strongly worded justification. So for example, F is increasing means that F prime is positive. So you're making the connection. F increasing is what I want. F prime positive is what I need. Do I have the graph of F or the graph of F prime in front of me?
F prime.
F prime. Where is F prime positive?
From 0
0 to 6.
Okay, we're gonna say from 0 to 6, is that right? Okay, now, parentheses or brackets?
Parentheses.
Brackets.
Parentheses.
Parentheses.
If you look at what we wrote, we said F prime is positive. So that would mean I'm not going to include the endpoints of 0 and 6 because at 0 the first derivative is actually equal to 0, not positive. And at 6 the first derivative is positive. I'm sorry, at 6 the derivative is equal to 0. Pretty good? Make sure you're like, hey, I've made the connection here. F increasing, F prime is positive. I get to award you a point there, and then get me the right interval. Okay, enjoy the ride. You guys can and you should definitely talk to each other. Did you just say whatever the F is? No, that was not you.
Has a good extended line. F prime.
in order to be concave up, it has to be increasing. And it's increasing from negative 4 to 3. That'll be negative 4 to
When it changes, as prime changes.
Because she was confused, so would it be increasing negative and positive? But there's no, when the other one's not changes from
yeah.
in this case, it doesn't.
That'll be negative 4 to 3.
So with negative, since it's negative, and then that would be negative. No, you would say, one after, so you would switch it, the other way, the other way. You're right, because your answer is at X. So you have to start.
I want to make sure the kids at North Central get to see all the conversations.
They're never on camera.
Oh yeah. Even see, we'll help more the judge. I'll make him look like a good citizen.
No, we're trying to help you look like a citizen.
Keep going.
So when at, you know that one.
I feel offended by that.
Is,
I'm just jealous.
That's
alright. Keep working.
Negative to positive. Because that happened. At X equals 0, there's
Good enough.
You can literally just write because you want to change from negative to positive when it's equal to 0.
That's what I'm saying. That's why it's not like this.
Why, oh why am I not smart enough to start the timer?
Negative 4 to 0 and 0 to 3. Or I just say negative 4 to 3.
Here, right?
Allowing it to increase here, right?
Okay, but this is negative, which means decrease, right?
It's not true. Our work is constant. The variable is how much we want.
Oh.
No, it's not.
Hi, Mrs. Figueroa. How you doing?
It was.
We'll play back the film.
Okay.
Go hard.
This means definitely quantitative,
But I'm asking about the graph of F. What does it take for F to be concave up?
That's alright.
All right, friend Steven, here you go. All right.
I mean, I got that.
All right, let's take a look at A through F, and then we're going to do the last couple together.
Yeah.
Okay. A, we already talked about this. F is increasing. That means F prime is positive. I have to see that connection. That connection is your justification. And then we're going to say on the interval 0 to 6. Now, here's something special, Stephen, when you're Googling things at night. Some textbooks, some calculus teachers say F is increasing. That means F prime is positive. And you say on the open interval 0 to 6, they will also accept, they being the College Board, will also accept the closed interval 0 to 6 for some definitions and reasons we're not going to get into right now. So if you are a brackets person in the world of increasing and decreasing, it's okay. I'm going to make the move over to parentheses as often as possible because our definition of increasing says F prime is positive, strictly positive, which means I shouldn't be including the endpoints. But brackets would be acceptable for increasing and decreasing. Part B, where's F decreasing? F is decreasing, that means F prime is negative. That's going to be on the interval -8 to 0. I'd say 1 point for the justification, 1 point for the answer. C, find the x coordinate for horizontal tangent lines. Horizontal tangent line, what do I know? That means F prime is equal to 0. 1 point. X equals -8, x equals 0, x equals 6. Get all three of them. Second point. Classify the extrema. When I say extrema, I mean relative max and relative min. So F has a relative max where?
Doesn't have a max.
F doesn't have a relative max because
F prime doesn't change from positive.
F prime doesn't make a change from positive to negative.
You have to say that.
That would be a good idea. Okay? F has a relative minimum at x equals 0 because F prime changes from negative to positive. Everybody good? All right. F concave up. Well, if F is concave up, that means that F prime is increasing. Now, is it also true to say that F double prime is positive? If F is concave up, F prime is increasing. If F prime is increasing, F double prime is positive. But here's the problem. You don't have a graph of F double prime. What you have is F prime. So your argument has to go back to what you see, and what you see is F prime. So you'd say on the interval -4 to 3. And lastly, part F, on what interval is the graph of F concave up and decreasing? I need both things happening at the same time. F is concave up and decreasing means F prime is increasing and negative. Where am I increasing and negative? -4 to 0. How many guys got like all of those? We're in a good place? Or almost all of them? I can take almost all of them. Almost all of them. All right, G, H, I, and J. These I want to go over as a group because there are some tricky things here that we haven't really talked about yet. G, not quite so tricky. Okay, take 30 seconds on your own. X coordinates for all the points of inflection. I need justifications here. F has a point of inflection. You've got that gold sheet. Use it if you need to. I can see answers, but I don't see the justification. This is going to be a place where life is bad. Aaron, here you go. Okay. Alrighty, friends. So for part G, F has a POI. What do we know about F prime? Andrew, what do you know about F prime? If F has a point of inflection, go back to the gold sheet if you need to.
Oh, okay. F prime is increasing. Well, F prime is increasing from -4 to.
Okay, let's be careful. Look on the gold sheet. Andrew, stay with me. F has a point of inflection means what about F prime?
F prime changing from.
Is changing. What's the change?
increasing to increasing.
From increasing to decreasing, where does that change happen? If you look at the graph, where does the graph of f prime change from increasing to decreasing? It doesn't happen on an interval. It happens at a place. It happens at a point. Where's the point, Andrew? Where does f prime change from increasing to decreasing? X equals 3. Is everybody okay with x equals 3? Okay, so this implies at x equals 3. Now the mistake is to be like, hey, I'm done. Aaron, why are we not done here? Andrew said f has a POI, f prime changes from increasing to decreasing at x equals 3. And I'm saying we're not done. What's the other thing that you have to check for?
If it changes from, or I mean, if the function
What function be specific?
prime
Okay. F prime, what's the change here?
from decreasing to increasing,
Decreasing to increasing, where does f prime make that change?
it's
Where does f prime change from if it's decreasing to now it's increasing? At x equals -4. Now at x equals -4, there's something else that's happening. You know that the graph of f prime has a cusp point, but I'm not actually worried about that because I'm asking where is f prime changing from decreasing to increasing. That's all I care about. Pretty good. All right, H. H, if f of 2 is equal to 5, determine the equation of the tangent line to f at x equals 2. Equation of a tangent line. We've done lots of these. You guys know exactly what you need if you're going to write the equation of a tangent line. 2 things are needed. Those 2 things. A point and slope. What's the point?
2, 5. X equals 5.
The point, if f of 2 is equal to 5, that means you've got the point 2 comma 5. What's the slope? Have some conversation with someone near you. How would you find the slope at 2? Okay, it seems like most of the folks are thinking, oh, tan. At x equals 2, that's what I want, right? Another notation for this is f prime of 2. Anybody know what f prime of 2 is? Don't overthink this. What's f prime of 2?
About 2.
It's about 2.9. That was a scary thing to hear. It's about 2.9. You should be able to tell me exactly where it is. Carmen, what's f prime of 2? Square root of 8. How did you get that?
You just plug in 2 into the equation, x minus 3 squared plus y squared plus
Okay. Carmen, one more time now that we've got the graph in front of us. Because David, I hear you say f prime of 2 is like 2 point something. You were estimating it? Carmen's not estimating it. She knows exactly that it's the square root of 8. How'd you get that, Carmen?
You plug in 2 into the equation of x minus 3 squared plus y squared equals 9.
Right, the equation for this circle is x minus 3 squared plus y squared is equal to 9. So I was being a little tricky there, right? So if this guy here is telling you the equation for the circle, then you can say, oh, well, at x equals 2, what Carmen just said, 2 minus 3 squared plus y squared is equal to 9. 2 minus 3 is negative 1. We've got 1 plus y squared equals 9. Y squared equals 8. And the really good algebra students are going to say y equals plus or minus the square root of 8. But polynomial, not plus or minus the square root of 8. Why not? Why not the negative? Not because of the domain restrictions, but look at the graph. Right, what we're estimating is the y coordinate up here, and don't you know for sure it has to be positive value. Okay? So if f prime of 2 equals the square root of 8, then write the equation of the tangent line. L of x is going to be slope, square root of 8, times x minus 2 plus 5. Nice job, Carmen. All the friends okay? Friends at North Central are okay? All right, now here comes the push. Is it part I, where they ask for the estimate? Is that what's happening in part I? Using your answer from part H, estimate the value of f of 2.4. I want an approximation for f of 2.4. And don't do anything crazy. I don't need anybody to simplify. I just need an approximation. Right. L of x is the equation of the tangent line. The tangent line is how we approximate. It is how we approximate the function. So f of 2.4 is approximately what I get by evaluating L of 2.4. L of 2.4 is going to be the square root of 8 times 2.4 minus 2 plus 5. What is that as an answer? I don't care. Don't simplify. All you can do is throw away a point that you've just earned. Anna, are you okay? All the friends up front okay? All right, now for the tricky part. Is this an overestimate or an underestimate?
Overestimate.
Overestimate. Tell me why.
Well, I just looked at that.
You looked at the graph. Oh, love it. You looked at the graph, and what did you notice?
That in order to put a tangent line, it only touches one point of the graph. That's the relation.
So what I hear you saying is at like 2.4, like this guy over here, that the tangent line is going to be above.
Yes.
So that would give you an overestimate. Does everybody agree? Everybody agrees?
Yeah.
No one wants to disagree?
Okay.
Nobody at all? I bet there's like 5 kids at North Central with their hands up in the air. They're saying, no, Mavericks, don't make this mistake. What graph is this? What graph is this? F prime. You're making decisions about F using F prime. That's the mistake. It is a deliberately nasty, trick you up, make you feel bad about yourself kind of question. So here's how it works. You need to be able to tell me about the graph of F on this interval. X equals 2 to the point that we're approximating. X equals 2.4. Does anybody know anything about the concavity of F on this interval? I'm asking you about concavity of F. What you see is the graph of F prime. You might want to go back to the gold sheet. Concave up? Why? I'm sorry, what?
Oh, because the function, f prime of x is increasing from x equals to
From x equals 2 to x equals 2.4, F prime is increasing. So tell me about F.
It's going to be concave up.
F is concave up. So tell me about those tangent lines.
It's going to be below. So
They're going to be below, and so your estimate? Underestimate. Let's go over that again. Okay, so tell me about the interval. From x equals 2 to x equals 2.4. I want to talk about the concavity of F, but all that you see in front of you is F prime. What do you know about F prime? F prime is increasing. What does that tell us about the concavity of F? F is concave up. Now, I care about the concavity for a reason. That tells me something. If my graph is concave up, those tangent lines, the tangent lines are going to be below the graph. So tangent lines are below the graph, and so your estimate? Wait, yeah, it's one of those two.
Under.
It's going to be an underestimate. Underestimate. Totally tricky. Think back to like 3 minutes ago where the 11 of you, all 11, were like, it's an overestimate. Of course it's an overestimate. I can see the tangent lines would be right here. And Myra, what was the mistake that all 11 of you made? You looked at the graph of f prime and we're thinking about concavity conversations here. And I'm not trying to pick on any of the 11 of you. I just want to make such a big point about this. It is the mistake you're going to make again and again and again. You have to tell me about the interval. You have to tell me what the graph that you see is doing. You have to relate that back to the graph of f, which is what I really care about, and tell me about tangent line behavior. Everybody good? All right, so with that said, let's push one more time. I want you guys to sketch the graph of f double prime. I just realized I never took attendance. Shame on me, and I did this job. And bad planning on my part, I don't think we're going to have the little quiz.
Oh no.
Bummer. My apologies.
Wait, so would f double prime not exist?
I think so too.
So it could be negative the whole time.
Right.
No. No, but it's negative. Oh, you no. That's
All right, friends. Let's we're off to a good start. For the, if I can get you guys to pull back together. Okay, for the sake of my being able to see the graph of f prime and sketch the graph of f double prime at the same time, I'm just going to put the sketch of f double prime on top of this one using a different color. Okay, so the black is going to be f prime. The neon blue is f double prime. Things that we know about the graph of f double prime because of what you see about f prime. Celeste, get me started.
At x equals -4,
At x equals -4,
f double prime does not exist.
at x equals -4, f double prime does not exist. Are we okay with this? Why?
Because f prime of x at x equals -4, there's a cusp point.
So f prime has a cusp point, which means f double prime does not exist. Great. Now, unfortunately, I can't actually graph does not exist, but I bet there are things that we could graph. Look at this graph of f prime. Are there other things we know for sure about f double prime? What you said is 100% right, Celeste. Myra.
There's a root at x equals 3.
Now let's be really specific. There's a root. There's a root on the graph of
F prime. Double prime.
f double prime. And the reason why f double prime has a root here is because
F prime of x has a horizontal tangent.
f prime of x has a horizontal tangent line. F prime horizontal tangent. Okay, anything else other people know? We've only got 2 minutes. I want to get as much of this as we can. Other things you know for sure about the graph of f double prime. Celeste and Myra, you're frozen for a little bit. Other things we know for sure. How about on this interval here? Anybody know anything about f double prime?
Looks like it's
F double prime has to be negative, and I bet you can tell me negative what?
1.
Right? You've just got a line. Celeste doesn't quite understand frozen. Aaron, can you explain frozen for her? She's a little bit lost there. So thank you. That's exactly it. So F double prime equals -1 in this entire interval, but not at -4. How about this next interval? It's going to be +1. Now, what about over here at x equals 0? I'll tell you, F prime has a problem over here. F prime has a problem. Bummer, we're out of time. F prime has a cusp point. It's not as sharp and pointy as this guy over here, but it's also not smooth. Remember, we need smooth, rounded. And so you're going to be undefined over here. Okay, tomorrow we'll finish sketching these other two pieces because that's going to be really important. Tonight's homework is the assignment for lesson 27, which is all the graphical analysis stuff.